In your Big Bang content page, we learn about how the universe was formed from the singularity during the Big Bang, how it expanded. Now, a couple things that they talk about are like quarks and gluons. These are just very, very, very small particles that turn into or combine to become all of the things that we see today. So, I want to talk to you here about atoms, a little background intro to atoms. If you look at all of these different pictures, plants, animals, humans, rocks, cheese pizza, jellyfish, computer, brick wall, and I ask you, well, what are they built of? What are they made of? You might say that animals and humans and all living things are made of cells, brick walls made of bricks and minerals, minerals for rocks, metal, microchips for computers. But if you could look even smaller, you would find that all of these things have something in common. They're all made from what we call atoms. Now, an atom is the smallest unit of matter that retains its elemental properties. You should add that to your study cards. What I mean by that is that an atom actually is made up of a couple things. It's not the smallest thing ever. As you saw from your timeline, quarks stick together with gluons, making protons and neutrons. But we're just going to focus on the atom. And you have to know that an atom is made up of three things. It's made of protons, neutrons, and electrons. Now, protons, the name pro, these are positive particles. Neutrons, like the name, are neutral, and electrons are negatively charged. Okay? So let's look at a carbon atom, right? All atoms are made of protons, neutrons, and electrons. If you look at the carbon atom, you can see these red dots floating around the middle. Those little red dots are the electrons. Then you see the black and blue here in the middle. You can see that the blue ones are protons and the black dots are neutrons. Turns out that the neutrons and protons, they stick together. They call that the strong nuclear force, strong force. They're always going to be stuck together and they make up what we know as the nucleus of an atom. Different than the nucleus of a cell, but same idea, the center, the bulk of it. Okay? So then what you might notice is that, well, here I have a carbon atom, I have a magnesium atom, and a calcium atom. They are all atoms, but these atoms are different. In our universe, on our planet, in space, there's many different types of atoms. All atoms are made of the same stuff, but there's different types of them. Can you tell what the difference is? Well, it's obvious. The difference is the number of electrons and protons and neutrons makes different types of atoms. So scientists decide they call these the elements. Different types or different forms of atoms are called elements, and those are atoms that have a unique composition and unique characteristics. Turns out that when you have different numbers of protons, neutrons, and electrons, it gives the atom certain characteristics. Like carbon, right? That's solid at our temperature and pressure. Excuse me. Carbon is a solid at our temperature and pressure that we live in. If you look at something like oxygen, well, we know that oxygen is a gas at our temperature and pressure, and that's because oxygen has different numbers of protons and neutrons and electrons, which give it different properties. These are all the elements that we know, not only on Earth, but in the universe. And some of these we made in a lab by forcing protons and neutrons and electrons together. Other ones exist naturally out in our Earth and in the universe. But there's something interesting. When you look at a periodic table, which is what this is called, it'll tell you about atomic number at the top of the element symbol. This one's oxygen. And the atomic mass. Here's a couple more terms you need to learn. The atomic number is very simple. It's just the number of protons. The atomic mass is the number of protons plus the number of neutrons. And then something you can understand for now, you'll learn more about this and how it changes in chemistry, but the atomic number, the number of protons, it usually equals the number of electrons. So if I ever ask you how many electrons are in oxygen, you can just look at the atomic number and that'll tell you, okay? Of course, that'll be different when you go deeper in this and learn about ions and chemistry, but we're just getting the basics here. So if I were to ask you, can you tell me how many protons and neutrons and electrons an oxygen atom has? It's actually very simple. All of the information from the periodic table can tell you that. We know that the atomic number is the number of protons. So if the atomic number of oxygen is 8, then there's 8 protons. And since electrons equal to protons, there's 8 electrons for this basic case. Now, if we want to find the number of neutrons, we can do a little tiny bit of math. If the atomic mass is the number of protons, which you know is 8, plus the number of neutrons, which we don't know, let's just call that n, and it tells us that it's 16, then we can figure this out. 8 plus what equals 16, right? Subtract 8 from both sides. You get n equals 0, 8. So there's 8 neutrons. Since the atomic mass is the number of protons and neutrons, that number is 16. And we know the number of protons, we just think, well, if the atomic mass is 16 and we know there's 8 protons, how many neutrons does there have to be? There's 16 protons plus neutrons minus the 8 protons we know. That leaves us with 8 neutrons. Simple.